So I'm Jeff Underhill from ARM, Director of Server Programs, and been with ARM for about 5 years now. It's been a pretty interesting journey thus far. When I first joined ARM, a lot of the conversations we had, people just said, wait, hang on a second, you just said ARM and server in the same sentence. Did I hear you right? And here we are a number of years later, and just a couple of weeks ago, HP launched their first commercial ARM-based servers. They've got 2 cartridges for the Moonshot chassis, so we've made a lot of progress in that time. Today I want to talk a little about some of the other things that ARM's doing and why we think it's time for a better cloud or a different way to do this. So very quickly, a brief introduction to ARM. Some of you may be familiar, some of you may not. The company's been around for 23, 24 years to this point. We're all about delivering IP for processors. We also have GPUs, we have interconnect technologies, we have memory controller technologies, but we span a broad spectrum from tiny, tiny little microcontrollers that would go into sensors and games and microwaves, car braking systems, things like that, all the way through to 64-bit CPUs, fully out of order, speculative, multi-core with high bandwidth network connections on chip and things like that. So really a very broad spectrum of solutions today. We're the global leader in licensing of this IP. I think this is a key point because it's a bit of a different business model to how a lot of other things operate, and it to some degree builds on what you guys are familiar with open source, and that is some fundamental building blocks that we provide to innovative companies, and then they take that, they innovate around it, they build on that, and that's how solutions come to market. So ARM as a company, we don't make chips, we don't make boards, we don't make systems, but we essentially produce software that other people turn into chips that go into end solutions. So ARM as a company has been around for over 20 years. During that lifespan, our partners have shipped 50 billion chips. But what's interesting is 10 billion of those shipped last year alone. So when you look at the trajectory of growth there, 50 billion over 20 years, but 10 billion in the last year alone. And then just yesterday, we put out our Q3 earnings for this year and announced that 3 billion chips had shipped in the prior quarter. So we're on target to do 12 or more billion this year. And the split of that is roughly 20% embedded, 16% into existing enterprise, so network equipment, enterprise storage equipment, and now servers. The bulk of the business, of course, comes from mobile computing, so smartphones and tablets. And then there's also some in home, in digital TV, home gateways, and things like that, which is going to become an increasingly important role going forward as we see Internet of Things and increases in sensors and things like that. So at the heart of this, and the heart of a lot of what's been discussed here this week, is cloud is fundamentally changing technology and how businesses operate. If you look, a lot of the large companies that exist in the cloud, the Googles, the Baidus, the LinkedIns, we all expect to interact with services via the web and via cloud-based services today. It's just how things happen. Not that long ago, we weren't shopping online, we weren't consuming content online. Now the vast majority of shopping and access to media happens via the web. There's been explosive growth there. It's also putting pressures on more traditional enterprises. The economics of the cloud have meant that internal IT organizations are under increasing pressure to offer on-demand self-service services and to meet some of the economics that people could otherwise attain in the cloud. We heard Battery Ventures talking this morning about Netflix and how that allowed them to just spin up instances quickly, do their testing, only use it for the duration they need. And as a result of this cloud transformation, there's new paradigms in software and through the value chain where traditional server vendors have had to become a little more agile and change some of how they're developing their systems, because sophisticated cloud companies are going directly to ODMs and specifying the systems they want. They want a different type of server. They don't necessarily want a lot of the bells and whistles that a traditional enterprise server may have. They want stripped down, very lean, mean, fast to deploy solutions, and we're seeing that on the software side as well. So, at the other end of this, what's driving it? We lead increasingly connected lives. There's been a lot of talk about mobile data and some of the challenges in the previous talk here as well, the IP address hopping, because so many accesses now come from the mobile space. And it's estimated that by 2020, each home, a family of 4 with 2 teenagers, will have up to 50 connected devices in their home. Now, I see somebody raising their eyebrows there at that number right now, but it's kind of interesting. I'm sure if you actually sat down and went through some of the things you have in your home today, you can probably reach 20 or 30. I know when I configured my home router, I only provided a certain number of addresses, and I actually ran out of DHCP allocation, and then it suddenly dawned on me that I was getting IP conflicts because I got too many devices on the network. So obviously we're a precursor to where a lot of other people will be, but I don't think that we're too far away from or on a trajectory to meet that. Part of this is coming from mobile computing. Everybody wants to access the data whenever, wherever they want. They're on the road, they're on the train, they're traveling. So this massive growth in mobility is largely responsible for that. But also a lot of that is actually changing a lot of lives, and smartphones are enabling people to do things that they couldn't do before. Some examples here. So even in South America, mobile banking, changing health and allowing people to get health services in remote locations that weren't possible before, improving disaster response to response teams and things like this. And these are all great things, but they all drive increased connectivity and increased data, and therefore put a strain on the network and what needs to change there to accommodate that growth. And that's before you even look at things like Internet of Things. So if you look at connected devices today, you have some fairly distinct segments that are responsible for driving the traffic. As you look to the Internet of Things and wearables, you're not going to have those distinct categories. There's going to be a much broader spectrum of devices, all needing IP addresses and communicating over the web. So that's just going to drive lots of traffic, lots of endpoints, and some of the challenges that we've been talking about here this week are just going to be magnified by that. So 26 billion installed units by 2020. That's a huge amount of data. Obviously, it's all got to be served, it's all got to be load balanced, it's all got to be secured, et cetera. So there's some fairly big implications on that. So just looking back a little at where we've come from, I'm talking about sensors to servers and the spectrum of ARM solutions. So if you look back into the 1960s at the Apollo guidance computer, this thing weighed 30 kilograms or 70 pounds. It was a big piece of kit. It ran at 2 megahertz clock speed, which is unheard of today, like 2 megahertz. What can you do with that? Had 72 kilobytes of ROM and only 8 kilobytes of RAM, and consumed 55 watts of active power. We all are carrying way more power than that in our pockets on a daily basis these days. So just to put that into perspective, this is a little microcontroller from Freescale. It's 2 millimeters by 1.6 millimeters squared. If you look at that relative to, so the big white sphere in the background there is actually a golf ball. That's a dimple on a golf ball. So this has a tiny, tiny little microcontroller in it, running at 48 megahertz. It's got way more performance and memory than the previous example I showed you. So intelligence is going to be built everywhere. We're already seeing home automation, security, wearables really starting to take off, and all of these devices are going to be generating data. It's all got to get back to the cloud, or in the future we're going to need intelligence throughout the cloud in order to do local processing and local decision on some of this data, because as you'll see, I think with that data growth, everything can't go back to the cloud. There's got to be some local processing. From an innovation standpoint, we're also seeing these tiny, tiny little low-cost development platforms come out. So one of the talks previously was saying about innovation. I think it was actually Gus during his keynote. He mentioned as a musician, he can now record his own music at home, put out an album. Same thing's happening in IoT and wearables, where people can get access to low-cost technology, combine that with open source, develop their own products, bring them to market through Kickstarter programs and things like that. So they're targeting this massive platform, which is all of us, wearable things, things we carry, sensors that we may have. So this is going to be one of the largest platforms that the world has seen. It's literally going to be ubiquitous. And so I have a few examples along the bottom there. Arduino is a very popular development platform. ARM has one of its own called Mbed. People are probably familiar with the Raspberry Pi. That really took off. We've seen people building clusters out of Raspberry Pi and running server-like workloads. And a company called Electric Imp, which have this tiny little SD card. They've embedded a microcontroller and Wi-Fi into it. So you just plug that into your tablet or whatever, You can drop files on there, you can program this thing, and then you can take it and install it somewhere else and use it as a little controller. So I think we haven't even seen the extent of innovation that's going to spawn from some of the things that are going on here. So the predicted implication of all of that on data is that data is going to grow 10x between 2012 and 2020. And this is going to be a problem. The network infrastructure itself has to adjust to accommodate this. The amount of data that people are expecting to have available to them anytime from anywhere is going to grow significantly. And that's going to have implications on everything that we do, and certainly the Nginx community and the software community in order to accommodate that too. So with IoT, and really machine-to-machine has been going on for some time, but it happened as largely silos of things communicating with each other. Now all of that is moving to be traffic throughout the web and mashups of integrated services, and that's why this infrastructure as a whole is going to have to shift to accommodate that. And that's a good thing in that it presents opportunity, but it also has some challenges. So smartphones, tablets will continue to drive growth. We're seeing new applications are developed with a mobile view, or a mobile first. They realize that they have to have a mobile accessible version of their applications. We're seeing people get interested in hosting instances of mobile platforms in the cloud. Wearables and IoT are going to be driving intelligence throughout the network. Some people refer to this as fog computing now, where not everything can go back to the cloud. It's got to expand throughout the network infrastructure. Being able to make localized decisions and making sure there's no single point of failure for critical sensor applications. There's a lot of talk about big data as well, but big data starts with little data. All this sensor information that's going to have to be groomed, processed, served, it's going to have big implications. And then the network and data infrastructure itself is converging. What was a server historically and what is a server today is already different, and that's going to continue. And then we're seeing technologies like SDN and NFV come along where you want programmability throughout your network. You've got to be able to construct these dynamic networks and reconfigure them on the fly to accommodate all of the traffic going forward. And that's something that we like to refer to as you need an intelligent, flexible cloud. Intelligence has got to move down into the network as well. Everything's got to go back to the cloud ultimately, but that needs to be a flexible infrastructure that allows you to grow, scale dynamically, and have the efficiencies that you need to accommodate the masses of data that are on the horizon. So another thing, we all refer to cloud, and there's lots of pictures of fluffy clouds painted, but the reality is there's quite a lot that goes on between our mobile phones and the data center, that we refer to as the cloud. You've got these radio access networks, you've got wireline networks, then access networks, aggregation networks that put that together, the core network that distributes all that data before it gets back to a data center somewhere located remotely for processing. So as the data rises, as the number of endpoints increase significantly, this whole infrastructure is going to have to be looked at to determine what can be done to improve the efficiencies, allow the whole network to scale, and to have locality of data and decision making in the right place. We've seen some of that with the Netflix talk, where they're talking about taking control of their CDNs. Obviously, it's a very large example. They have a massive amount of data and a lot of users. In this case, it's kind of flipped the other way around, where you've got tons and tons of endpoints. All of that data's got to be aggregated and processed, and potentially local decisions made, especially if it's sensor data. So cloud infrastructure, this is putting challenges on the network operators. They've got to accommodate new business models with cloud-based services. They've got to grow their network in order to accommodate the masses of data that are coming online. It's already huge, it's getting bigger. But they've got to do all of this while balancing their own capital and operating expenditure. So they're kind of caught in the middle of these somewhat opposing forces. We're all demanding better user experiences too. Not only do we want that data whenever, wherever, we want high bandwidth, we want low latency. We've become accustomed to that. And I know if I find myself somewhere now with a slow pipe or struggling to get connectivity, it's not a happy situation. I'm sure you guys have experienced that too. This is all creating demand for higher performance networking equipment. It requires more intelligence and management and autonomy closer to the user in order to improve the user experience. It requires a flexible but standardized processing architecture. That we've heard about SDN and NFV where people want to move certain functions into software. So having a consistent architecture across that will also be beneficial. And we need ubiquitous access to these services, right? They've become somewhat mission critical. I know some of you wouldn't consider Facebook and Netflix mission critical, but those of you that have teenagers and have had network outages probably find out otherwise. So networks and server equipment essentially converging. Historically, servers were very general purpose things, and you had networking equipment that was more fixed function and purpose built. Going forward, we believe that throughout that network infrastructure, you're going to see combinations of processing, storage, acceleration in different mixes to meet the requirements, whether it's that access network, the edge network, the radio networks, or parts of the core network. And what's traditionally in the cloud is going to start spreading out throughout the infrastructure and getting closer to where the users are in order to offer a better experience. So to look at that a little bit more, if we look at a traditional 2P server, this has already changed, but there's a lot of discrete components in there that can be collapsed down into a single chip in order to integrate things, save costs, save power, make things smaller so you can increase density. And that's one of the things that ARM's business model is all around. We've been building SoCs, or our partners have been building SoCs from day one. That's how mobile devices are even possible today. So servers are going to become increasingly specialized in order to get to that next step level function of efficiency. General purpose servers are good at lots of things. They may not excel at any particular thing. When you've got a workload and you have tons and tons of instances of it, you want to optimize for that particular workload in order to get the efficiencies, and the economies of scale are there because you may have a small number of workloads running millions of instances. On the flip side, traditional networking equipment was very specialized and purpose-built. And so on that side of the equation, they're looking to get some of the benefits that the server guys have enjoyed for years with virtualization and flexibility of doing things in a software environment. So the network infrastructure is looking to become increasingly flexible. And you've got this kind of convergence of those two things in the middle with software-defined X, and I say software-defined X because it's almost every day there's a new software-defined storage, software-defined networking, but the overall goals are largely the same, and that is to achieve an accelerated pace of innovation, to offer more flexibility and manageability, and to meet the scalability and efficiency needs of the network and the cloud-based services that people are offering. We believe one way to achieve that is to have a broader choice of solutions in the market that are in themselves more specialized, but then a spectrum of solutions that allow people to pick the right tool for the job, if you will. So ARM and our partners, they take ARM intellectual property, whether that be CPU, GPU, memory controllers, etc. But where the magic really happens is once you start taking those building blocks, combining them in interesting combinations, and blending them with partner-specific intellectual property. This is where the magic really happens. If you think about it, the open source community works like this. Things get put out there, people look at it and say, oh, there's a better way to do this, or I could extend it in this way. Oh, these two things kind of belong together. I'm going to merge these things. And it's a little like how the ARM ecosystem works. Sorry, we have standard cores. Our partners may have networking and storage equipment capabilities. They may have workload accelerators, bulk encryption, things like that. And they're able to stitch those things together in combinations to provide compelling solutions to the market. So one example here I want to talk about is the Applied Micro X-Gene. This is a 8-core part running at 2.4 gigahertz. It has 40 gigabits of networking integrated directly on chip. You can drive up to 64 gigabytes of memory. We have a couple of examples of this at the ARM table outside. There's the Applied Micro Moonshot cartridge. And because everything gets condensed down into a single chip, it means you've got a very, very low latency connection to the network. It means that you can design very, very small servers and increase your density. And the power consumption can be less because you've got one single chip instead of multiple discrete parts. There's a white paper that HP has done with more insights that has some details on some TCO benefits for web serving. I've got the link in here, so you'll be able to get that later, and I would encourage people to go check out that paper. So HP officially launched their ARM-based cartridges about 2 weeks ago at ARM TechCon, and comparing them to some of the other cartridges that they have available today, they were able to offer double the memory capacity and up to 4 times the density compared to traditional servers. So these are some fairly significant changes versus traditional architecture. And starting in November, so just a couple of weeks away from now, they will have a developer program where people can access these devices remotely to develop, test, and optimize software. We've already started to do that with Lenoro, which is an open source organization where we're hosting some servers in the cloud to help the open source community work on things. And of course, the ecosystem is coming along. Just yesterday, we had the announcement with HP and Nginx that Nginx Plus is now available for 64-bit ARM-based systems. And I'll talk a little more about the software ecosystem here shortly. So a couple of customers that have already got their hands on these parts and are playing with them, Sandia National Laboratory, the University of Utah, and PayPal. And a couple of key things that these guys are already seeing through their initial experience of working with ARM servers is increased energy efficiency. So the ARM heritage comes from efficiency. That's why all the mobile devices run on the ARM architecture today. Energy efficiency is just fundamental to everything that ARM does. People are looking for lower cost, higher density, and lower power consumption. This all boils up to TCO, right? So when you have a large installation, TCO is king. Everybody has their own equation to determine their particular TCO, but fundamentally, price, performance per power, per area is the fundamental premise. And then in the case of PayPal, they're using a part that has some integrated DSPs to do some pretty heavy math work in order to detect fraud and things like that in real time. So having specific solutions that are more tailored to the job at hand allows people to optimize to a level that was previously not possible. So another example, Dell had a storage proof of concept that they showed a couple of weeks ago at the ARM TechCon. The reason I bring this up, there's been various discussions here this week about CDNs. And I think putting data closer to the users in order to provide a good experience is a great example. In this example here, the area at the top there's actually 2 small processor cards, each with an Xgene processor on there. You can populate 1 or 2, and then you can change the ratio of compute and networking to storage depending on your application. And in this particular chassis, you can have 1U and put up to 12 drives in there. So a great example where if you were to combine that, you've got the storage. If you were to run Nginx as your CDN application on one or both of those servers, this would be a good general purpose content delivery server. 40 gigabits of networking per card as well, so you can kind of adjust that ratio depending on what you're doing. They were actually running Ceph on here. If you run Ceph on a single node, it takes about 28% CPU utilization, so you don't need both cards. If you wanted to do some more heavy lifting on the data that you've got in there, then you may want to put in the second CPU card, and you could, Hadoop and offline analytics would be a good workload for that. AMD has also announced their processor, codenamed Seattle. They have their silicon back. They've started doing demonstrations. They've demonstrated Red Hat on there. They were at Java 1 a little while ago demonstrating Oracle 64-bit JVM on there. And I believe they've talked about shipments later on this year going into early next year. So another option that's coming to market, giving people choice. And then another example is Cavium. So this is Cavium and Applied Micro. You may or may not be familiar with them, but they both come out of the networking space. So they've got a lot of domain expertise in networking, network offload, accelerators, and things like that. They're combining that with the ARM CPUs now into a server solution. One thing that's interesting with the Cavium example is they're actually developing 4 different SKUs of the same product, tailored at compute servers, storage servers, network and telco servers, and then a special secure version that has more specific offload engines for security and things like that. So this is how the SoC model can work in a partnership of taking standard off-the-shelf building blocks, combining it with unique IP that people may have, and then making different combinations of those to tailor solutions for specific market so you can deliver a compelling solution for a given workload. So that's a lot of hardware. What about the software side? So ARM architecture, the current generation, is something we call ARM v8. Prior to that, the ARM architecture has been a 32-bit architecture, which limits the applicability for server and workloads. With v8, we've added 64-bit, but a key point of distinction there is we didn't just take our 32-bit instruction set and extend everything to make it 32 bits. We've actually created two distinct execution environments so that we could start a clean, fresh 64-bit instruction set and not necessarily carry over a lot of baggage. So by doing that, it's been architected from the grounds up to be an efficient 64-bit architecture. One example is all instructions are 32 bits in length, so it's very easy to decode. That lends itself very well to dynamic code generation and JITted environments and things like that. We carried over all of the previous capabilities, though, in the 32-bit execution mode, so it's compatible. We've extended it with crypto, so we have AES instructions natively. I've had a couple of questions this week about OpenSSL, so that's in there. And then we've beefed up the floating point, SIMD, engines, and everything in there as well. So I mentioned it's backward compatible with 32-bit code, less of an issue in the server market specifically. But again, it was developed in conjunction with modern languages like C11, C++11. We have load, acquire, store, release primitives in there for efficient thread synchronization. And it's just a very modern instruction set that aligns very well with today's programming languages. So there's a lot of software already available for the 64-bit ARM architecture. Canonical has released their OS. They have, I think, over 40,000 packages already ported over to the ARM 64-bit architecture. They've got hundreds of applications available. Clearly, this is a very important part of being able to deliver solutions to market. Nginx is the most recent addition with the announcement this week, so we're really excited to announce that partnership and have Nginx come to this platform. We've done a lot of work around standardization to ensure that portability of software is at a level that would be expected in the server environment. So that's why I have some of the key kind of foundational technologies on here. And then we're participating in a lot of the open source projects around virtualization and cloud infrastructure and provisioning, as well as some of the network function virtualization. Open Data Plane is another organization that was mentioned recently. They're looking to create an open data plane sort of structure and API that allows people to take advantage of some of the accelerators that are in there, so you can take advantage of the performance, the full performance entitlement. So Canonical announced their 1404 LTS release earlier this year. The LTS is important because that stands for long-term support. So this is their server OS that they offer 5-year support on. This is available for ARM 64-bit systems today. It's currently the only commercially supported operating system. And as I mentioned, they've already got 40,000 packages ported across and hundreds of applications available today. 1410 should be released any day soon for Canonical. They have a 6-monthly release cadence, and that is the OS that becomes deployed on the HP Moonshot systems. Red Hat, who you may have seen as part of the video this morning that I had, they've been working for a number of years on ARM support in the Fedora community. They're at a point now where they have a partner early access program, so they're providing access to their 64-bit OS to partners. This is partially so they can collaborate in an early stage, get people to play with this, get feedback, identify early opportunities for optimization. A key goal here, I mentioned the standardization, is creating a singular 64-bit ARM server platform. So they've been very active in the standardization efforts to ensure that we can have a single kernel release that runs across all 64-bit servers. They're also looking to enable a faster pace of innovation by working with a partnership like ARM, where you have a much more frequent cadence of solutions coming along to choose from, which is different to the typical server market. And of course, a key part of this for them is to gather requirements, understand use cases, and better tailor their software to ARM-based solutions. So just coming back to this convergence piece and the fact that this extends throughout the network, because I do think that's an important component. ARM obviously has solutions from tiny microcontrollers all the way up to very high-end CPUs and GPUs and things like that. And we will see all kinds of combinations of this combined with with third-party intellectual property into solutions for storage and networking, as well as servers and things that are combined. And working with Nginx, we believe there's an opportunity to extend what would traditionally reside in the cloud, take that down into the network, home gateways and things that have to aggregate data and serve data, networking equipment where people are trying to put intelligence and caching of data closer to the users. These are all areas where processing of lots of HTTP traffic is going to have to occur, and as the endpoints increase, this is only going to become a bigger problem. So having a very efficient way to handle that is absolutely key, and that's why we're really happy to have worked to get Nginx Plus on ARM. And then just to mention the press release that went out yesterday, if you want to obtain more information, obviously you can go and check out the press release, check out Nginx website, or come and talk to us here. We're happy. I put my ARM shirt on today, so I'm easily to find, so we can have those conversations. So in summary, 64-bit ARM servers are shipping today. There are already hundreds of applications available. We want to talk to people and understand your stack, what your requirements are, and see if there's a way we can work together towards that. Nginx Plus is now available. Driven by a strong desire to optimize TCO for these large installations, there's definitely a shift underway towards more workload optimized solutions that increase the density and reduce power and costs. ARM partners have been developing SoCs for years. This is fundamentally our business. That's what we do. And our partners are busy doing that. We're already on our third or fourth generation of server SoCs today. The business model is built on partnership, and a lot of people talk about partnerships, but fundamentally that's how ARM comes to market. We're completely dependent on our partners to deliver solutions to market, so we work in a true kind of collaborative partnership environment. And with that, I would love to invite you guys to work with us, explore the benefits of ARM and Nginx for your particular workload. If you have specific needs, then please come and talk. We're open to any and all conversations. And with that, I would like to thank you and see if anybody has any questions. No questions. Yes?
I have two questions. So on the last slide, there's a commercially available 64-bit server available from HP.
Yes.
And that runs Ubuntu?
Correct.
Okay. Completely unrelated to that.
Yes.
In the microprocessor that you showed in the golf ball pencil,
Yes.
those things cost in volumes?
That's a good question, and one that is best directed to somebody like Freescale that makes that. But I mean, they're going to be pennies, is my guess. I mean, they're probably sub-dollar type devices. Yeah. Yeah. Yes.
You mentioned servers.
Yes.
What about the handheld devices like mobile phones or tablets? Are there any sold right now which
There are some examples of that out there on the web. So 64-bit is already starting to occur in the handheld space, and that transition is occurring quicker, I think, than most people originally expected. So there are some in market today, and I think you'll see a lot more on the not too distant horizon. Given our business model, ARM licenses IP, so we're quite far up the value chain, and then things happen. So you can probably take a look at some of the announcements of who's licensed ARM's Cortex A53 and A57 and kind of follow the chain as to where that's coming. But yeah, they're already in market. In fact, 64-bit cell phones shipped before 64-bit servers did, which. That's a good question. I would imagine 64-bit, but it's backwards compatible, so people have the option. Typically what we would see, and sorry, the question is, are they running a 64-bit operating system? Typically what we would see is somebody running a 64-bit operating system and either virtualizing for 32-bit or running 32-bit apps under the 64-bit OS. If you have a 32-bit OS, then you can't run 64-bit apps, but you can the other way around. So, yeah. Okay, any other questions? Then thank you all, and appreciate your time, and we'll speak to you over the course of the remaining time here. Thanks.